everyone, we are Team 5. Today we'll talk about the part of the structure of Apple Park with the voice lab concept and its supporting girders. One of the important architectural features of Apple Park is floor-to-ceiling glass partitions with no visible metal trim top or bottom. The desire for the architectural ceilings to remain uncracked and for the members themselves to remain elastic in a 1.2G vertical acceleration event, combined with the narrow envelope of acceptable deflections, led to the development of a press-dressed long-span unit with a continuous bottom flange. Numerous old designs and prototypes were created. This figure depicts a rendering of a double I formation. The top flanges of precast support metal decking and a concrete fill-on-deck diaphragm. This section was structurally effective but difficult to form and strip in the precast plant. After several studies, this was the final figure. The figure at the top shows the profile of the unit, and the bottom one shows the reinforcing and press-dressed cross-section. Now we'll get in more deeply. The total precast cross-section allowed the ceiling surface to be utilized as a structural flange in combination with the structural stem units supporting the floor above. The use of press dressing in the section kept the slabs from cracking under surface loads and the limited deflections to at the 1.2G vertical acceleration event. A press-dressed concrete structure is a structure in which the concrete is press-dressed, meaning that it is treated to develop tensile stresses in advance. As shown in the figure, a member subjected to bending will bend downward, creating tensile stresses at the bottom. Concrete is considered to carry very little tensile stress, so to get the most out of concrete, it must be made so that it is not subjected to tensile stress. If we think of a beam bending downward and stretching at the bottom, we can cancel each other out by bending upward beforehand. So press dressing is a strategy of applying compressive forces to the member first, so that it will have little tensile force later. So back to the content. The final design produced floor units with a deflection profile after creep of quarter inch to minus quarter inch on a 43-foot span. The live load deflections were less than 3 per 16 inch for the same span, and the seismic deflections at 1.2G were less than 3 per 4 inch at mid-span. So, what are live loads and seismic loads? Live load is a long-term load that acts on a structure and refers to the load of equipment, furniture, and people, and is characterized by size, distribution, and fluidity, and it is difficult to predict changes in load size. On the other hand, seismic load is one of the short-term loads that act on a structure and is generated through ground shaking, and seismic design is the main safety measure for seismic loads. So back to the content, the shift slab units included metal decking pre-installed spanning between the stems, and the narrow deck pieces that connect two units also shipped and hoisted with them. After the decking was complete, a conventionally reinforced 4-inch thick lightweight concrete diaphragm was poured on top. So, what is diaphragm in this context? In structural engineering, a diaphragm is a structural element that transfers lateral loads to the vertical resistance elements of a structure. Diaphragms are typically horizontal but can be inclined, such as a gable roof on a wood structure or a concrete ramp in a parking lot. Diaphragm forces tend to be transferred to vertical resistance elements primarily through in-plane shear stresses. They were considered effective for seismic combinations and deflection considerations. However, due to reduced cover, they were not considered effective for strength combinations in a fire. The fire-resistant design relied on additional strengths and mild steel up higher in the stems with adequate cover. Mild steel plate, also known as plain carbon steel, is a type of carbon steel that contains a low amount of carbon. It is the most commonly used form of steel due to its low cost and versatility. Mild steel plate is easy to weld and machine and can be surface hardened through processes such as carburizing and nitriding. However, it is susceptible to corrosion and requires protective coatings or treatments to prevent rusting. The 2.5 feet deep notches in the flanges created challenges as well. The flanges were pre-stressed with 14.5 feet diameter strands at an elevation of 2 feet 3/4 inch above the finished surface, meaning they touched the tops of the notches. Also, the notch in the flange is thinner than the rest of the flange. It generated the strongest shear force. The following figure shows an FE analysis of the shear stresses caused by pre-stressing. FE analysis, which stands for finite element analysis, is a computer simulation process used in engineering analysis, which provides an easy to understand representation of the stresses on a structure. As shown in the figure, we can see at a glance that the more red the color of the bottom of the slab, the stronger the stresses. These notches also created a shear lag effect during pre-stressing that required additional hunches to get the flange pre-stressing forces over the notches without inducing principal axis cracking. So what is hunch? In concrete structures where the thickness or height of the member changes, it's easy to cause cracks in the structure due to the concentration of stress. To prevent this, the part of the structure where the vertical member and the horizontal member meet is called a hunch. Again, back to the content, a buttressing pyramid was used as a hunch to prevent stress concentration. As shown in the FE analysis, we can see that the overall color has faded and the structural geometry has improved, unlike the previous figure.
Before we talk about the supporting girders, we will explain what girder is. Since a girder and a beam have the same function, some assume that a girder is just another word for a beam. However, just as all thumbs are fingers, but not all fingers are thumbs, all girders are beams, but not all beams are girders. Girders are a type of beam with the capacity to support large loads, including other beams. Girders have some significant differences that are important to understand. Beams are the primary part of the structural framing system that will carry the load. Beams are intended to bend to resist and redistribute the load. Girders, on the other hand, are more rigid, as they are there to support the beams and provide the main horizontal support for the structure. The girder is built to support significant or encompassing loads such as structural pillars or beam responses. In general, if it is there to support other beams and carry the load bearing weight, it's a girder. Let's get back to the content. With the void slab cross-section and structural member design determined, the end support of the void slab were all that remained to be solved. The void slabs rest on ledges of precast post-tension girders, or on a continuous ledge at the shear wall lines. The support connection chosen was a trussed anchor bar, a rectangular steel bar with well-inclined rebars that transferred the reaction into the stems of the units. The girder and wall ledges were designed for the concentrated reaction. The soffit space below the girder was shrouded with either an architectural beam cover or partition framing where walls were placed. The slanted opening of the soffit provided space for return airflow up into the as well as a place to mount lighting. The picture shows a cross-section through the girder. These girders repeated themselves at every interior radial grid line. Also, the girders also had to perform as collector elements, delivering more than 400 kips of force to the shear walls. This was managed by doweling 4 bars into the girders and having them protrude into the stem of the shear walls. The member detailing for the remainder of the load path became much more conventional. Single-lift precast columns start running through the girders and connected to upper columns with Type 2 splice sleeve connectors, and single-lift precast shear walls with the same Type 2 connectors. To go deeper in precast concrete structures, assembling various concrete segments on site requires important connecting accessories. Type 1 connectors are usually simpler in design and are commonly used for basic connections where moderate strength and stability are required. Type 1 connectors have a lower load capacity compared to Type 2 connectors, so they are suitable for lighter duty applications or where the loads are relatively modest, but they are more readily available and are simpler and easier to install. Type 2 connectors can be offered in various sizes and shapes depending on the design of the structure. Type 2 connectors are designed to provide high tensile and shear strength, making them suitable for structures that needs to withstand greater loads. They ensure a stable connection even under complex or heavy load conditions. Due to their high performance, the installation process of Type 2 connectors can be more complex compared to Type 1, which may affect the construction periods and costs. Through the utilization of precast post-tension girders, engineers have crafted a robust system capable of bearing substantial loads while maintaining structural integrity. This is the end of our journey for structural parts. Thank you for listening.